of the Computational Humanities Research Group. We have quite a couple more scheduled for this semester. But today I'm very excited to be introducing Miguel Escobar Varela, Associate Professor at the Department of English, Linguistics and Theatre Studies and Deputy Director of the Center for Computational Social Science and Humanities at the National University of Singapore. In his research, he uses digital tools to document and study cultural heritage in Southeast Asia. He's author of The Theatre as Data and has written several articles on digital humanities and Indonesian theatre. And today he's going to talk about computational theatre research, leveraging large data sets and AI for the performing arts. Thank you so much, Miguel. The floor is over to you.
So thank you very much, Barbara. It's great to be here with all of you, and it's very exciting to also be in this room where people are interested in the computational humanities. As I said, now I wear many hats at the National University of Singapore, where I've been for about 10 years now. And the role that I'm most excited about is, as you said, that I'm deputy director of this new Center for Computational Humanities and Social Sciences. So part of what that means is also I'm interested in reaching out to similar centers and to connect with researchers like those of you here in the audience who are interested in this kind of work. So what I thought I would do is I will try to keep this to half an hour or so and give you a sense of the things that I'm interested in by describing a couple of projects. So I guess that, as Barbara mentioned in her introduction, I'm interested in cultural heritage, particularly in the performing arts, print media, digital spaces. And I guess that the question that it's always in my mind when I look at these things is a question about change. I want to know how things change over time, both the production and the reception of this cultural form. So I'm interested in how the style, the format of things has changed over time, but also the ways in which things are consumed, engaged with, and interpreted. For this, I use computational methods whenever possible, typically like NLP, image processing, network analysis, but also I rely heavily on non-computational methods such as history and ethnography. And one of the things that I always try to do when I embark on a project like the ones I'll describe is to ask when to use data. And even though I'm a firm believer that data can open up many new avenues for research, can help us uncover unexpected patterns and bring in new solutions to the surface, it's not the only method that should be used, and it shouldn't be always used. So I think that only certain kinds of questions can be answered with computational methods. These are important questions, but it's not necessarily every question that we might have when we're talking about culture. My approach is to work towards incremental answers to questions that can be narrowly framed around available data. And you'll see plenty of examples of these in the examples that follow. And I'm also interested in always paying attention to caveats and cautionary tales. And I'm wary, as I think we should all be, about digital chauvinism. We're thinking that always the method, if a computational method is better than any other alternative. And so I try to, I'm definitely like a technology enthusiast, but I try to keep this enthusiasm in check and remind myself of all these sort of things. So, maybe to kind of bring this into a more concrete series of examples, I want to take you a little bit to my world here in Southeast Asia, where I'm based. I've lived in Southeast Asia for about half my life. Before coming to Singapore, I lived in Indonesia. And one of the things that fascinate me is this tradition called wayang kulit, which is translated as leather puppets. And puppetry has different associations in other parts of the world. Here, this is the most important theater tradition. It's something that is for adults. It's not for children. It's not for families necessarily, but it's for really kind of, it's a very elaborate art form. A performance usually lasts about 8 hours. And it's a bit more like opera in the sense that it has all these very complex conventions for music, for movements. It's full of literary allusions, and it's been around for like a long time. The documented history of Wayangkulit in Indonesia dates back at around 1,000 years. And I can talk about this forever, but that's not really the objective here. This is just to set the stage of the things that I'm interested in. So, again, I'm interested in questions about change, and I want to. This is a form that has changed significantly over time, and there are some portions of this question of how has it changed that might be amenable to computational methods. There are some aspects of these questions that are tractable as data. Some are not. So let me just kind of show you kind of something that is not, just to kind of as an intro. So one of the, these are very long performances, as I said, like about 8 hours. And one of the most popular parts of the performance are these comic interludes. These interludes can be about an hour long. There are typically 2 interludes in these performances. And you have these recognizable figures. These are like gestures. This one is called Petruk here in the traditional form. This is like a modern reelaboration where you can see like a version of the same puppet clad in contemporary clothing. And he's been reimagined with a more like, English sounding name. So instead of Petruk, he becomes Patrick. So anyways, these are kind of like, people have traced these kind of like little changes over time. And there's, plenty of room for, historical ethnographic research, but there's also kind of other things that we can do with computational methods. So let me show you kind of one project that we did that tries to do that. So the stories that are presented in these Wayangkulit shows are adaptations of epic tales that are found in South Asia. So some of you might be familiar with the Mahabharata and the Ramayana. These like epic tales from South Asia that have been also adapted and interpreted to different parts of Southeast Asia and elsewhere. And so one thing to note is that these are like super long stories, and typically in a single Wayangkulit show, you would not show the entire epic. You would show like a fragment, and in that fragment you have certain characters that appear on stage, and you have like a story about them. So what we did is we constructed a network where I'm just going to play here. And so here what you can see is that these characters are represented as nodes, and there will be edges between them when they're part of the same story. So we have a bunch of other kind of information here, like the family relationships. So this is a typical story. You see like a blow by blow description, and these are like this is at the scene level. So you can see the characters that are together in the same scene. So you can see some structure that emerges at the at the level of an individual story. But we can also look at the overall structure of these characters. And in the network that emerges, so if you see like this overall network where you see like all the characters that are connected, if they are co-present in a single scene, you get to see ways in which the stories have changed over time. What do I mean by that? So here, the ones that are pink in color are characters that you also find in the South Asian versions of the stories. That like if you're familiar with kind of term like Krishna in Indonesia, Krishna in India. So these are characters that are pink, and then the characters that are represented as green are characters that are of Javanese invention, like Petruk, the same one that we saw earlier. So one thing that was surprising is that we kind of collected this sample of stories. Everything is on GitHub, and I'll show that later. The proportion of characters is about the same. So the characters that are Indian in origin is about 53%, Japanese characters 47%. And these took this surprises even people who are well versed in the tradition. So when we ask people to their estimate, they say that they expect that it's only about 30% or less that are Japanese in origin, but in reality it's about half. But then if you look at quantitative metrics, and just to give you an example here, we're looking at degree. So the degree is the number of characters that one of these characters will be connected to. So you can see that there's like this huge spread of degree distributions in the characters that are originally from India or South Asia, whereas the Japanese characters are either like bunched together towards the bottom, or they have like these characters that tend to have very high degree, which are the clown servants. And what this suggests is that even though the characters are equally common, they are imbricated differently in the fabric of these stories. And this is a purely network phenomenon. So if you were to just count the occurrences of the characters, they would also be about the same. So it's not that they appear in more scenes, but they appear in more scenes with more characters. So they tend to be in these more important scenes, if you like. And so what is interesting for us about this is that it's a bit of it's a proxy for this measure of cultural evolution. It shows how these ideas that have over the 1,000 years of adaptation to Indonesian, how new characters have been invented and adapted to this tradition. And people invent all kinds of characters, but they don't add them in the same way to the story. And we also, this is just like a preview of this research. We also did some null models, and there's code also for reproducibility. So basically what we try to do is to do multiple, hundreds of thousands of simulations of networks with the same characteristics and see how unlikely is it that we see something like this very stark separation between characters based on their origin. And it's something like, that is pretty significant in these, pretty uncommon in these simulations. So therefore, the effect of a mechanism in this case, the ways in which the characters are used in the stories. We also are looking at the place of the performances. And another kind of mystery is that I spent a lot of time speaking to people in Indonesia about these performances, and they would often tell me that, oh, this was very common before, but now it's disappearing. And we kind of wanted to know if that's true, or so we collected data from social media and we validated it. So this was like a couple of research assistants and myself, and this was done for only the period of 3 years. But one thing that we found is that at least in those 3 years, the number of performances between 2016 and 2018 was pretty stable at around 5,000 performances per year. So you can see this is still like a very robust tradition in that sense. But one thing that happens is that, here you can see this map, this interactive choropleth, this heat map, where you see the multiple regencies. There'll be provinces or districts, and how the performances move over time. So kind of, so this looks a bit like a beating cart. And what is interesting about this is that it shows that the performances kind of remain constant, but they move over time and over place. So there are certain times of the year where you have more performances. There are certain areas where suddenly all the performances move around here, or they move to another place. So if you are a spectator, you are living in one place, you might lose sense of these rhythms. And that might lead you to believe that this is disappearing, whereas it's just maybe happening at another time or another place geographically. And we also found, so another thing we asked is some people say that this is a more of a rural form rather than an urban form. And that kind of one of the reasons why it's disappearing is because as Java becomes more urbanized, there are less performances. But what we found is that there's no correlation between any measure of population density and the number of performances. So other things are at play. So here the density and the number of performances, there's kind of no kind of real correlation between these metrics. In other words, this is not primarily a rural or an urban phenomenon. Okay, so one of the things that we also were interested in doing is kind of estimating how common these performances are. And there's no real census. There's no there are not a lot of really good metrics for this, but we have a lot of proxies that we can use. We have these mentions in social media, but the other that those seem to be stable, over time. But other sources of data, in this case, is from YouTube. So we looked at the metadata that we can obtain from YouTube through their API. And the number of Wayang clip recordings updated to YouTube has increased dramatically over time. This doesn't necessarily mean it's become more common. Actually, we don't believe that that's the case, but it's become easier to upload recordings because the cost of the internet has dramatically gone down, and also because the phones are getting better, so now you can record an entire performance of 6 hours or more and upload the entire thing to YouTube. So you can see like the number here has increased over time. So in the past 10 years, 2014 to 2024, there were 34,000 full-length recordings of Wayang uploaded to YouTube. So this is like a pretty amazing data set. And this is like 114,000 total hours. And you can see that the duration has also increased over time. So here we see like the median is the solid line, and the 25th and 75th percentile will be the shaded area. So you can see like the median video, like around 2022, is like almost 5 hours. And again, this is not a measure that it's increased in popularity. It just means that it's not decaying. So we believe that they're probably equally, you're as likely now as 10 years ago to see a performance in reality, but they're just a lot more available online. And these, there are kind of other things that we can do with these statistics. You can look at the number of views, and you can see also here like the median. You can see that in the year of 2019, the views skyrocketed, and then they went down. So I think anybody can take a guess on what you think happened, and you might probably get it right because it happened to you as well. It was the pandemic, and this was a time when live performances were you couldn't have like a live performance with audience, but the artists kept doing recordings of Wayang Kulit in their studios and their houses, and people kept watching them. So I just think that this is pretty kind of remarkable that like in like the median video, that has 20,000 views. I mean, just think about that. I think that's really kind of incredible. Like for a pretty kind of niche performance that is like hours and hours long, in this like archaic register of the Japanese language, that like a median video in 2019 had 20,000 videos. I think it's great. And it's and it's I mean, it shows you also that the popularity of the form, and like we start to see afterwards some that it kind of like maybe goes down to the kind of historical values of like how many views a particular video has. So I mean, there's lots of things we can do with this data. We're still trying to validate and analyze it and see to what extent can this be a proxy for the prevalence of these performances in the community. But there are also other things that we can do with this video, or that we could do with this video, and I'll talk to that in a moment. So let me mention one specific question that is amenable to like an empirical method. So many scholars assert that the comic interludes are getting longer. This is like a phenomenon that people like often discuss. They say like over time, these interludes that like traditionally would be like between like half an hour to 1 hour, these are getting longer. And this is reflected in different books, and some people see it as a very positive development. They say, "Oh, it's great that there's more comedy. These segments that are more popular, that are less elitist, they attract more people, so that's a positive thing." That with the view of this scholar Jan Marasek, and then we have like also here like Catherine Emerson that like wrote like records ideas of people who say that this is probably not great. That it kind of detracts from the philosophical core of the performances. But both detractors and supporters have this idea that the comic interludes are getting longer. So the question is, are they getting longer? And can we answer that with data? So what we did to answer that project was we labeled a ground truth data set of comic interludes. So we created this on Streamlit, and all of this is on the GitHub repo. I'll show you in a moment. So this is like where one interface where an expert can label the beginning and the end of the interlude. So here you can see, like, if you look at a series of screenshots taken, so these are like 15 seconds apart. So from this one over here to this one, there are like, this is like a 1 minute. So there's like 2 minutes in this here. So I can definitely see this is the beginning of the interlude and this is the end. Now, if I were to look at a single frame, like let's say I look at this one over here. Looking at that frame, I do not know if it belongs to the interlude or not. But if I look at this as a sequence, I can easily tell where it begins and it ends. One imperfect analogy that I can offer you is like, imagine that you were looking at a data set of TV shows, and that they also include that these TV shows also include the commercial breaks. Now, if you look at a single frame, a single screenshot taken from there, and you see like a person walking down the street, you don't know if that's the main show or if that's an advert. But if you look at a sequence, you can definitely see like the difference, and you can definitely say, okay, this is definitely where the advert begins and this is where it ends. Of course, this analogy is imperfect because if you look at adverts, they will be like, product shots and other kind of visual characteristics that can tell them apart that are not available to us here. But hopefully this gives you a sense that, like of why this is easy, and we were able to label pretty quickly like 100 videos, that are like, like we took only longer videos that were like, 5 hours or long. And we labeled 100 out of those videos at the beginning, at the end of these comic interludes. And then we worked on these a model like so this is a temporal model for action segmentation. So this is like a little bit like the way that those of you who work with like linguistic data, like it's a way to identify the beginning and an end of a sequence. And we took this particular model called FACT that has like extremely high accuracy for detecting the beginning and the end of a sequence, or like this like action segmentation. Now the data set that they use is extremely different from ours. So this like the data that they use is this thing called Epic Kitchens that looks like this. So they have a variety of people with like a GoPro strapped on their head that they look at the beginning, like they're kind of cooking. And here you have like actions like, cut bell peppers, or rinse bottom of AeroPress under tap. So these are like, in some ways like these atomic actions that are like, maybe more consistent in some ways. They're like, shorter in terms of duration. But we said, let's just give it a try. Let's see how well it works with our data set. So we kind of fine-tuned this model on our data set that is, only 100 videos. So I mean, like this translates to 800 hours, but still, like 800 videos, and each of my videos only has either the normal performance time or the beginning and the end of the comic interlude. So you have the comic interludes and normal performance. Now, I was not. That was like an experiment. And we said, let's see how well that works. And I thought like that would give us like an inkling of whether we were on the right track, but I didn't expect the accuracy to be great. But lo and behold, we have like our accuracy with this model it's like pretty high. Let me explain kind of what this means. So tolerance means that when you let's say that, I don't know if you can see my hands, but like let's say they have like these two fragments. This is like the label ground truth, and this is the actual predicted, the prediction coming from the model. So if you have like a very lenient overlap where only 10% of them must overlap, then our like F1 score is like 97%, 96.5%, which is still it's incredible. Like that we were able to do this just fine tuning this model. And then if you go to like 50%, the accuracy goes down to only 90%. But this is still like remarkable, I believe, for a model that was trained on an entirely different data set and with high quality but very small data, we were able to get these results. Now, of course, what we would love to do is to apply these on our like there's like 30,000 videos in YouTube. The thing also is like, how do we get like the rights to apply these? So we are kind of exploring options, like talking to artists, talking to organizations, to see if there are ways in which we can have like get the rights to analyze this data set, and we could answer this question at scale. Has the comic interlude expanded in duration or not? Again, like here the restriction is not so much technical. I mean, we believe that here, even within the with the boundaries of these possible error, that the tolerance is not great, we would still be able to at scale answer the question of whether it has increased or not. But the challenge for us to move forward is on the copyright of the data. But anyways, just as an example, we're going to be talking about this in a few weeks. So my graduate student and myself, we're going to be at in Aarhus at the Computational Humanities Research Conference, 4 to 6 of December, if anybody is there as well. And we'll be describing this project. And so on GitHub here, you can find installation, and we've got a script that does the entire kind of pipeline for running inference on videos from the terminal. We are also polishing the presentation of the model that's going to go on Hugging Face for people to reuse and extend. And yeah, so I think that's the, I see the time here that it's, let me just kind of like stop sharing for a moment and see how we're doing with the time. I have a kind of another set of examples about a totally different topic, but I think that maybe I will just, I mean, I can come to them if there's question, but maybe let me just, I mean, so I mean, I'm also interested in things like looking at the structure of collaborations in other companies. So I will just show you. I mean, I do a lot of like, network analysis over time to kind of to identify how things change, like and when things change, when the structure of collaborations changes over time. That's a slightly different topic, and I've already covered many different things. So I've talked about video processing. I've talked a little bit about network analysis as well, and a bit of these like data sources that we can obtain from social media and the geostatistical analysis. So I think it's already quite a lot. I describe some of these projects in my book, Theater's Data, which is was published by the University of Michigan Press in 2021. And this is open access. So if you go to the, you can find the link from my website, miguelescobar.com. You can read the book. You can also download the code from the website of the publisher. It's all in zip folders. But I also made a version of the code on this GitHub repository. So if you just go, again, you can find this from my miguelescobar.com. So here there's, maybe I just show, the theater's data here. So yeah, you can find the code and the data. Also, the book has like a section called the data biographies that includes like a detailed description of how the data was transformed. By the way, this comes with an MIT license, so feel free to reuse it for teaching research, or if you find any kind of errors, let us know, or let me know. This is it. And here, yeah, I was just like looking at the code, and I realized that one of the libraries called like PySal, which is used for geostatistics, now requires like 1 million dependencies that are really hard to get because they're all pretty old after 3 years. So I decided to refactor the whole thing to work with the new version of that package. And you can find here, you can install the packages if you want to run this locally, or also here you've got the Google Colab. So for example, if you wanted to look at this location on the Google Colab, you can, oops. Okay, anyways, I'm not on my computer, so apparently I need to sign in for this. That's a bit annoying. I'm pretty sure you don't need to sign in, but you can try. But anyways, this is the same code as what you see here. Let's see for the location. So yeah, this is kind of for doing this, like the kind of like the analysis of the location data, and you can run these. You can kind of fork the repository, clone it, or on the, if you go to Google Colab, it fetches the data directly from GitHub, so you don't even need to upload anything to like Colab. So we like if you want to just give it a run, we try to I try to make it as easy and seamless as possible. So yeah, so maybe this is kind of like a good place to pause at least for a moment and catch my breath and see if there's any. I mean, I can come back to the examples. I can explain other things, but maybe this is kind of a good way to kind of get a sense from the audience. So thank you.
Thank you very much. This was super interesting and really exciting to see the example of the code, and also to know that you're going to be in Aarhus. I'll be there too. So.
Oh, great! Yeah, fantastic. Yeah.
So yeah, thank you very much. Okay, so I'm going to stop the recording so people feel more relaxed asking questions, and so I'll do that in a second. Okay, yes, so